Hi there. Today on our board we are looking at this proof, and this is suitable for grade 12 who are preparing for their examination. So if you want more of this content, you can check on the link and also look at a 1 complete hour video that talks about this type of questions into detail also after finishing watching this video. So let's take a look at the question. This is proof that twice tan theta minus sine 2 theta over 2 sine square theta equals tan theta. So here, if I to prove something, then you have to see that there are two sides always, and the first side here is the left hand side, and here we have the right hand side. So when you're proving, you have to note that you need to select the most complicated looking side and reduce it down by simplifying. Now when you look at this, you realize that the first part here, that is the left hand side, is looking more complicated compared to our right hand side. So we have the basis of selecting the left hand side for our simplification in order for us to be able to get something similar to the right hand side. So with this said, let us move on and implement what I have just said. So firstly, we need to select the side we're working on to tell the examiner that we're working on left hand side, and this is equivalent to, then we copy our left hand side where we have twice tan of the angle theta minus sine of the double angle twice theta, and we divide this by the denominator, and our denominator is twice sine square theta. Now after that, we can distribute this common denominator to the two terms in the numerator. So for that case, we have it as twice tan of the angle theta divided by the denominator, and our denominator is twice sine square theta. Then we subtract away. The numerator here is sine twice theta is also divided by the denominator, and that is twice sine square theta. Here, literally we did not go far. What we have just done here is to split the denominator into the two terms of the numerator. So the next step here, we look at something that can reduce down, and I can see from here that, okay, 2 from the numerator and denominator in this first term can cancel, and again, when we look at this numerator from the first term is tan. Now, remember from what we learned earlier on in grade 10 that if you are given tan of any angle theta, and this is equivalent to sine of the same angle theta, we divide this by cos of the same angle theta. And again, when you look at this double angle formula of sine, we are given sine twice theta. This can be expressed as twice sine of half of this angle to theta is theta. If you have here 4 theta, then you have here 2 theta, because that is half of the angle here, which has been doubled. Now here we multiply by cos of this angle theta. So these are the two identities we're going to use in our work here. So let's move on and continue simplifying. Now here we can go on and write the numerator independently in terms of sine and cosine as sine theta by dividing this by the cos of the same angle theta, and after that we divide the whole thing. The meaning of this one is division sine, and we're dividing this by sine square theta, and we can put this over 1. Therefore, I think we're done with the first part here and the first term. Maybe we can put it inside a certain bracket like this, that we are first simplifying this before subtracting away what we have here. We can go on and split this in terms of half angle. Therefore, instead of saying sine 2 theta, we can say twice sine of the angle theta times cos of angle theta, and we divide this by the denominator, and that is twice. Now I want to split this sine square into 2 by repeating itself as also twice sine theta times sine theta. Here we have not made any change, we just simply made it simple in order for us to be able to see this clearly. Now from here you can see that we can cross one of this sign together with this one, and again these two will have to cancel. So we're gonna write the remaining terms. Therefore, we will change the division sign into multiplication. We know very well we don't use division directly in fraction. The best friend to division is multiplication. Therefore, we write our first term here, that is sine theta over cos theta. At this time, we're multiplying by. So, while changing the division to multiplication, we always interchange the denominator to the numerator and numerator to the denominator. And maybe I can show it here that this is going to swap down, meanwhile this one will swap up. Therefore, we can go on and implement that where we have 1 all over sine square theta, and we subtract away the remaining terms here, cos theta from the numerator, and the denominator we have only sine. We can move on and reduce this because I'm seeing something common, and that common term is sine theta together with 1 of the sine theta. So therefore, the only term left here from the numerator, because this one has gone to 1, 1 times 1 is also 1. We're going to have here 1 all over. So here we have cos theta, and 1 of the sine here, sine theta. And on this side, we have cos of theta over sine of theta. Therefore, let's move on and get this in the next page. And we also simplify it to one term. So we had 1 over cos theta sine theta minus cos theta also over sine theta. So let's put it here. And after that, we can look for a common denominator. So this common denominator, when we check on the first term here and the second term, sine is common. Therefore, our lowest common divisor is cos theta sine theta. Therefore, we can put it down here and say cos theta sine theta is our lowest common divisor. When you divide cos theta sine theta by cos theta sine theta, we get 1. And 1 times our numerator is also 1. So we can place it there. The overall result is 1. And we subtract cos theta sine theta divided by sine theta. The sine theta will cancel and we will be left with cos theta. So we're going to multiply that cos theta we have obtained as a result of dividing the denominators by the existing cos theta from the numerator. Therefore, we can simplify this down and we have 1 still persisting here, and we have cos square theta, and this is divided by the common denominator. So when you take a look closely also in the numerator, you can see that from one of our identities, that is grade 11, we have sine of any given angle with square theta plus cos square theta equals 1. Therefore, if we happen to make sine square theta the subject, will obtain 1 minus cos square theta. And this one looks exactly like the numerator. Therefore, we can replace the numerator by the single term, and that is sine square theta. Therefore, we divide this by the denominator, and our denominator is simply cos theta and sine theta. And maybe let me create more space. We can move that side and say this is equivalent, or things good to make partition here equivalent to. I want to repeat this sine square theta, splitting it into 2 so that you see clearly where crossing comes from. So times sine theta, and dividing by our common denominator, that is cos theta sine also theta. Therefore, we can see that, okay, sine is common, so we can cross one of these by that, or you can just cross this near one here. Therefore, we're left with sine theta and cos theta. And the remaining parameters here, that is sine theta over cos theta is exactly the same like what we quoted here, and that is tan theta. Therefore, we can replace this by tan theta, and this is equivalent to the right hand side. Since we selected the left hand side for our proof, we have just simply gotten our right hand side exactly tan theta. Hence, we have just proved it because the question is asking us to prove, and this is how we work out that. As I mentioned earlier on, you can go on and check the video that is popping on the screen here to get more of this kind of questions. And if you have not subscribed at this time, do yourself a favor by subscribing so that you don't miss out on the favorite videos that I'm gonna upload online, and also share this video and this channel with your friend. Remember, sharing is caring, and I'll see you in the upcoming videos. Peace out.